All right, so Happy New Year, everyone, and welcome to our first installment of the Type 2 Diabetes Knowledge Portal Platform webinar and workshop for 2020. We thought we'd kick it off today with inviting our intrepid engineers to present with us today. So we'll be hearing from them later in the webinar. So this will be exciting, a little bit more technically focused talk today. We hope you like that. But I'm going to begin with a little bit of an intro. But so today's goal is to talk about our topic specifically today is accessing the Type 2 Diabetes platform programmatically. You know, for many years, many of you hopefully have been using the portal as a UI, using our visualizations, our query tools on the portal. But today we're going to talk about other ways to interact and access the results we have built and represented on the portal. We're going to talk about that through APIs. And this is really a beginning of a next iteration of the Type 2 Diabetes Knowledge Portal. And it gives you sort of a preview of what we hope to be doing over the coming years as we expand the software platform to be more flexible and more modular and more adaptable to the influx of data, methods, and tools, and moreover, allowing us to be more interoperable with other types of resources, other software platforms, and also other means of accessibility. So that's really how we're trying to position ourselves. So Maria is going to start off and talk about, the gap that we're really addressing with APIs and the value by showing you what you can do in the portal and sort of leveraging how it will be valuable in APIs. And then Marc Duby, who's one of our principal engineers, is going to talk about, what are APIs and how do you access them and give you some demos there. And then Oliver, who's also a principal engineer on our team, he is going to show you the more practical use. If you're not a person who knows how to automate these APIs, someone who really wants to just run a specific query, Oliver's going to show you how to interact with that way. And then the team will be available for Q&A at the end. If you have any questions, again, feel free to pop them in the chat line as you go so you don't forget them. And so before we talk about APIs, I wanted to talk about what's been new since October. We've been busy. We are excited and a little nervous because we've applied to renew the Type 2 Diabetes platform for 5 more years. And we're really hoping that the NIDDK will like what we've offered up to do for the next 5 years. So we'll be hearing about that soon. And we talked about it in November in terms of the types of things we're thinking about it. Really turning the platform from just being a resource for human genetics data, but more to serve up mechanistic insights for all the loci we've identified for Type 2 diabetes and integrate data types, methods, and computational approaches that allow you to do that. So that's coming in the next 5 years. So hopefully they will like what we applied to do. Since then, we've also had 2 production releases, and I'm going to talk a little bit about what's on the portal now and what's new since October. And our sister site, DGA, has had 3 data releases, and I'll quickly touch upon that. So it's been an exciting time for us since October. You'll notice as you interact with the site, it's clean and streamlined. We've made a little bit simpler UI for you as you enter the site. There's sort of 2 main ways that you would enter the portal. One is by gene, variant, or region, and this gives you the different means of which you would interact with the site by a gene, a chromosome, or a region, and it's simply what you've seen before. And then you can explore via phenotype. You can explore the variant associations, the gene level associations, and the predicted Type 2 diabetes vector genes. And you can pick your trait and go to it from there. So it's a little simpler UI, a little bit more directed way of interacting with the site. So that's new since October. Also, we've had more data sets. We're now up to 84 data sets for 191 traits. Pretty awesome, but something to highlight. So the new data sets are now listed at the top of the data page whenever we have a release. And just a few to highlight I thought was really nice and of value to this group is that we released the Hermes heart failure data on the site with publication, I think last week officially. This is great collaboration with Patrick Eleanor and the Hermes folk and Tom Lumbers, who led the study. When the paper came out, we launched the results, and they're integrated both on the Type 2 diabetes platform and the cardiovascular one. And as we move forward to build the metabolic disease portal, you'll see them integrated fully across all the portals. So that's what's new. We also have some new data from our Singapore cohorts and Hong Kong cohorts, which represent the FNIH-funded AMP T2D data sets. So again, data is coming in readily, and we're integrating it as we go. So those are some things to look for as you query. Back in October, we also improved our interactive tests, partnering with Michigan, who really did a lot of this work. You now have better aggregation tests on the site to run custom tests with our exome sequencing data. And over time, this will increase to more quantitative traits across the 52,000 exomes for type 2 diabetes. And then finally, our sister site, DGA, has been very busy releasing data. And they release data ahead of us on their site so that you can query them there. So you can go there and see, I think 90 new accessible chromatin state data sets from Geo and ENCODE. I think he has released with his team 17 experimental data sets from recent publications. And you can query that on the news item seeing at the bottom of the page right there. And what's nice about this is eventually these data will be integrated in the platform for diabetes, hopefully in February. So you will get them in both sites integrated in 2 different fashions. What events are coming for us so you can know where to check us out and where to interact with us. We have another production release coming in February. As I mentioned, new portal design at that time, a little sleeker, as well as what we've seen recently. We'll even have more design features. We'll have our first version of the metabolic disease portal, along with data for complications and type 2 diabetes predictions improvements. We'll have new portal tutorials like we try and do routinely across these different topics. I'll be giving a webinar for DKNet. We were invited to do that. That's a broadcasted webinar, which may be interesting to check out on the 24th of February. And then, as usual, we'll be doing our exhibitions and talks at Endocrine Society, where Jason has a talk this year about the portal, and we'll be at ADA as well. So those are places to check us out. But we'll be continuing to do our webinars at the regular cadence of every other month. So turning to today. I think I've showed this slide at many webinars in the past. This is the software platform that powers the portal. So you have the place for data ingest, analysis, and integration with both individual and summary level statistics. And these are all stored in a knowledge graph database with all the integrated results from the computational approaches we run. We also have federation with DGA and EBI. But this all comes together in the lovely and elegant portal that you see and interact with every day. So that's great. But if you would like to automate some of the results you see in the portal, or if you would like to run a specific query on a command line, if you're a little more technically savvy than some of us who like to use the portal, you might want to use APIs. And how you would use those, you're going to hear about next. But basically what you see here is the portal has now been made available through APIs. So it's the same results that we produce in a beautiful web browser are now accessible with their APIs. It's kind of the sort of the broad high-level summary here. And we're going to continue to make better APIs over the next couple of years. But what we're going to talk about today is what you can do and how we're going to grow that activity. So with that, I'll turn it over to Maria to kind of talk through basically what you do in the portal now and how you might translate that into an API use case. So Maria, I will stop sharing my screen and turn it over to you.
Okay. So I just wanted to kind of briefly go over a few things that you might want to do using APIs. That some of them can be done with the portal, some of them cannot. But for these cases, it's actually more efficient to use the APIs to do it. So as you know, there are lots of ways to browse the portal and to search and do custom analyses. And so, of course, the APIs are not a substitute for that. But the APIs can be really valuable to do things that are difficult to do in the kind of one-off way that you would be looking at the portal. So here's a potential use case. So suppose you have a variant that you're interested in and you want to find all of the bottom line p-values for all the phenotypes. So this is bottom-line analysis is analysis that we've performed here. It's a trans-ethnic meta-analysis looking across multiple data sets. So as Noel just said, we have 84 data sets in the portal, but this analysis looks over all of the data sets that are available for any given phenotype. And it accounts for sample overlap between the data sets, which is increasingly important because as the data sets get bigger and bigger, they necessarily overlap in their sample composition. And so we do this using the METAL algorithm, which was developed by our colleagues at the University of Michigan. So to see these bottom line p-values in the portal, you can go to a variant page and look at the PheWAS plot. And then when you mouse over any of these points, you can see the bottom line p-value. But suppose you wanted to see the bottom line p-values for this variant for all these phenotypes. there is not an easy way to do that using the portal. You'd have to mouse over all the points in turn and maybe take a screenshot or write down the values. That it's not ideal. So Marc is going to show you how you can do this much more easily with an API query. Here's another possible use case. So if you have a region of interest and you have a phenotype of interest, how do you know which variants are most strongly associated with the phenotype in that region? So let's do the example here of looking for variants that are associated with type 2 diabetes at genome-wide significance, and then in this region on chromosome 8 between these coordinates. And so you can do this in the portal with the variant finder, which is a really nice versatile tool. But one of the first things you see when you go to the variant finder is that you have to choose a data set. And especially for type 2 diabetes, we have many, many data sets. Well, how do you know which one to use? That's not entirely obvious. And we've heard from users that it can be confusing. They don't know which one to pick. We do, document the data sets in the data page, so it's possible to figure out which one might be the best for your purposes. But so let's, okay, I was going to go through this query. So here, using the variant finder, how you would do this query is on this tab, select phenotypes and data sets, you would put in type 2 diabetes. I'm choosing the Diamante European T2D GWAS data set because it's about the biggest one we have for type 2 diabetes. It's almost 900,000 people. And put in the p-value. You click the Add Criteria button to add this to your query. And then on the Additional Search Options tab, the other tab, you can enter a region here, so chromosome and coordinates, and add those criteria. And then when you do the query, you do get a table of results. There are many more results than this. And you can download it, so that's good. But I think, so the variant finder at this time does not give you bottom line p-value results. That's something that the API can do, and that's, I think, going to become increasingly useful the more data sets we have. A third use case is that the APIs let you retrieve the results of computational methods, and there are several methods you can retrieve results for. But here's an example, the MAGMA method, which is a way of generating gene-level p-values for association between a gene and multiple phenotypes. We've run this in-house on the largest data set for each phenotype, and we are going to make the results available via the focus table on the gene page, but they're not there yet. However, you can get them right now with the APIs if you want. So that, and Marc will tell you about that too. So those are some reasons that you might want to use the APIs. Oh, and I wanted to show you briefly how to get to the APIs from the portal. So here's the portal homepage. Under the data menu, there is a selection APIs. Now this takes you to a page that's also in the portal, an informational page, and it has some descriptions of the APIs. But then this link here will take you to the Swagger UI page that Oliver is going to tell us about at the end. So that's how you get to this information from the portal. Okay, so now let's go to Marc.
Okay, so I'm Marc, and I'm going to talk about the REST APIs that we currently have available for people to use. So our current portal infrastructure is, so the web user hits a disease portal. The type 2 diabetes portal actually is in federated mode, so it by itself hits a knowledge base, what we call a knowledge base, which houses the REST APIs, and that is distributed across the Broad and the EBI knowledge base. The other portals we have go straight to a single non-federated node. And then as far as the Broad knowledge base goes, it goes to a Broad regular database and also a MySQL database and a graph database. So what we are doing now is we are allowing users to go straight to the single Broad knowledge base and query REST APIs. So why this architecture? So the reason this architecture was picked is because, well, for two reasons. One is it decouples the data and how it is stored, so the data architecture, from the actual display of the data. So it gives more flexibility to the portal to be able to query multiple data sources and decide how it wants to join those data sources to display all the nice graphics that you see on the portal. And then the second reason is because now also it enables, since a lot of the data, I mean, not only in the life sciences field, but across even financial other fields, a lot of data is aggregation of data across multiple services. And so in order for us to be able to offer our data, we have also now built in a REST service that we can just open for people to use. So people can either build, I mean, they can build their own tools that use our data to either display or just do calculations on the fly. So just what a basic REST call, at least the way we use them here, is they're programmatic HTTP calls, which means that they're pretty much the same calls as a web browser makes to any web server. Ours return JSON format, which I'll go through. I'll show an example right after this. We have a specific host, which we opened up and secured so people can use. And there's a path. So the same way a web page will have a path after the host, it's the same thing for the REST service. And then after the path, you provide the parameters. We're trying to keep these calls to be get type calls if possible, because they're a lot easier to document and a lot easier to manage. So everything at this point, anything you can run, any REST call you can do through your, let's say any language that you decide to query, you could also test it on Postman, which I'll show, which is a tool which nicely formats the result, but you could also test it in your browser. And there's an example just at the bottom of the slide here. So a sample REST call result. So this is a JSON format, so it's pretty much a map-based format where you have a key value. And we're moving all our calls to our standard. Any new calls have a standard, which is you get the key map data, and then after that you would get an array of elements which themselves have key value pairs in them. And I'll go through 3 of the calls that Maria just talked about. So I'm going to do a quick Postman demo now to go through these calls. So this is the Bottomline example that Maria had mentioned. So you get the host. Let me just there we go. Okay. So you get the host. If I can move this. So in essence, you get the host, you get the path of the call, and these are all documented in the Swagger page that Alfred will go through afterwards. And then you get the parameters. And this one here, it's just you're giving it a var ID, a variant ID, the format that we use, which is chromosome underscore position underscore ref allele underscore alt allele. And then these are the results. So these are the bottom line results for that particular variant. So you get, and they're sorted by rising p-values. So most significant p-values are first. And then you get, so here pretty much you get the p-value, standard error beta. You get the basic information on the variant. You get the var ID returned to you just so you can verify. You get the phenotype and the phenotype group. And this goes down for pretty much all phenotypes that we have for this particular variant. So if we go all the way to the bottom here, I'll end up in a cardiovascular group phenotype SVP, which is
systolic
blood pressure. So that's one call that Maria had mentioned. So we also have a region bottom line result call, which is here I provide a limit here. So we're going to have hard-coded limits on these calls just to make sure that, I mean, there is a drain on the database, and if the calls get too big, then they can severely impact the database. So we will have limits on these, which will be documented on the Swagger page. So I'll put 100 here. You have a end position, start position, chromosome, and the phenotype that you're looking for. So these are per phenotype, and then all this is documented on the Swagger page. And this is pretty much, these are all the variants that we have with their p-values for type 2 diabetes. And again, they're in sorted order, from most significant to least significant. So another thing quickly to point out is that the last part of the path is array or is object. If I change this to array, so this is a very verbose way of describing the data that comes back. If I switch it to array, it'll come back to a more, a less verb. So every piece, so there's a header at the bottom. I should have picked it different. So the header will tell you, so it's the var ID, then the p-value, then the standard error. And in essence, all these arrays are going to be in that order. So the top section you're going to get is going to be all the, these are going to be all the var IDs, and I think the p-value is next, if I remember correctly. Yes. So there's just a more, if you're querying a lot of data and the result is really large, I mean, this is really if somebody really wants to, you know, if they just want to streamline how much data comes back and how quick it is, it's just another option. And then we have the Magma call that Maria mentioned. And here it's genes. Actually, I can't necessarily speak to the data, but here it is. It's what exactly is Magma?
I can't tell you exactly how it works, but okay. it calculates a gene level p-value, significance of association with a particular phenotype.
Okay. So again, just to reiterate, this is just for informational purposes. So the structure of the REST call is the host, the root path, and then the internal identifier. The internal identifier will determine what the call is, and then the object. So the format is at the end, and this does not include any of the. I mean, the parameters will vary based on the call. Some will take genes, some will take variants, some will take positions. So let me I'm going to go through a Jupyter. So just a quick disclaimer, I'm a Python newbie. So, but I just decided I would just do a use case on what I would believe somebody might decide, how they might decide to use this call. So if I take, actually.
Can you make that a bit bigger too, maybe?
Yes.
Great.
So I'm going to grab Maria's example, vary it and pop it in here. So right now here I have 1, 2, 3, 4, I believe I have 6 variants. I'm going to add another one here, which is the variant that Maria was using. So I'm going to use pandas. I can't really speak to pandas. All I know is it's a nice data structure used by a lot of data scientists, and I believe it runs off of NumPy. It uses some of the NumPy data structures. So here I'm building the array. So the array now has Maria's new variant in it. So here I'm just running a quick, so this is the actual query API. The brackets will be where the var ID will be put in. I create a new data frame, clean data frame, which will contain all the results. And then for all the variants in the above list, I'm actually looping through them, making a call for each variant. First, I get the actual string. Then I make a GET request, so a REST call to our service. Then I get the JSON out of the request. And then from the JSON, I create a new temporary data frame, which will just read the data portion of the call. So in essence, it'll read all these lists. And then after that, I'm adding the temporary data frame to the master data frame. I'll print out just to keep an eye, just to sanity check that everything's working okay. And then at the end, I'll have a fully loaded master data frame with the 10 top results for these 7 variants. So here I have 70 results. So if I just decide to look at the 15 first rows of the data frame, it pretty much has all the data, and it's sorted by variance, and then after that it's sorted by ascending p-value. So we can see here that variance 10 to 15 are actually, this right here, 10 to 15 are actually a different variant than the one above, than the 10 above. So just to make it more readable, I'm going to filter the data set into something that's a little easier to read, which is this one right here. So here I'm just keeping the var ID to p-value, standard error beta, and phenotype. So same thing, it's still sorted by variant and then by this ascending p-value. And so, I mean, at this point, a data scientist can do whatever they want with the data. For me, just out of curiosity, I want to see what are the most significant p-values of all the variants that I have, regardless of variant or phenotype. So it's just sorted by p-value. And I run this, and then I see actually that Maria's example actually came in at second and third position, and then also that there's a coronary artery disease variant, which I happen to pop in there, which is, I believe, this one. And so this would be a way, if somebody really wanted to have a library of variants that they want to look at, they can easily programmatically pull all the data and then, in essence, run whatever reports they want on the data or any type of visualizations they'd be interested in.
Great. So this would be good for someone who's like working in R and wants to extract the results and sort of work with them in a programmatic space or run their own computational method, right? That uses these data as input. Is that right, Marc?
Yes.
Cool. Great.
The great thing about this data is at the bottom. So Noel mentioned the new Hermes. I'm probably mispronouncing it, but the Hermes data set. Every time we get a new data set, we recompute all the Bottomline values, at least for all the phenotypes that data set has. So these are real time, these are, as opposed to just shipping files around and doing the studies, these are real time values that you're getting straight from us, which are based on all the data sets that we've currently loaded. So the values that we have today will be probably a little bit better in a month, and it'll probably be a lot better in 6 months, would be my guess. This is just real-time data. As we aggregate these data and as we run all these computational methods on them, we're trying to make them available to people so that they can actually use them in their own research. And that's it for me.
That's right.
Okay. Hi, I'm Oliver Ruebenacker, and I quickly talk about OpenAPI and our Swagger web UI that you can use to learn about our APIs. So what is OpenAPI about? So the problem here, if you have any kind of client-server architecture, is that you always have to keep the client and the server in sync. Like, you always have to make sure that any kind of request that the client will issue is understood correctly by the server, and any kind of response the server issues is correctly understood by the client. That can be fairly burdensome and very easy to get wrong. If it's the same team and the same language, you might share some code between client and server, but that's often not the case. You might have, let's say, a Java server and JavaScript client, or Or you might have two different teams that are responsible for server and client, which is, well, the case in our case. We have a server and we're hoping that other people write the client. So how do you make sure that the client and server are in sync? So for this reason, there is what is called, the solution would be you write first the API spec in a way that is machine readable. And then you use that to either configure or to generate servers or clients. So you could have, let's say, if you have a dynamic language like JavaScript, more likely you would write something that takes the API specs as a configuration to create the right API. Or if you have a more static language like Java or Scala, you more likely would use the specs to generate code that represents the API. And so once you have the API specs, you can use this to create different servers and different clients by different teams in different languages, and ideally it should work. And one approach is called OpenAPI, formerly known as Swagger. So it started being called Swagger by a company called SmartBear, and now it's called OpenAPI, and it's carried by a big consortium of all kinds of software companies. And it's an industry standard, basically. It's very widely used. And the specification itself is written in JSON or YAML. And there are various tools you can use as an online editor. I believe there is a plugin for IntelliJ to write these. And there's a Swagger code gen, where you can generate code in a large number of different languages and platforms. And it's also not that hard to write your own code generation module. I did one because I didn't like their options. So I wrote one in Scala, for Scala, with using STDP and Cersei. And they also offer, one of the tools they offer for free is the JavaScript web UI, which you can use to give it your specification, and then it generates a nice web page to explore and use the API. And that's basically what I'm going to show. One caveat, our server is not generated using OpenAPI, but it was generated in other ways, and then we wrote the OpenAPI specs after the fact. But it's useful for people. So there might be differences between the OpenAPI specs and the server. So, but we can fix that if you. So now, get out of this, and so yes, so here is the page. It can be reached from our portal. Shall I show again how? Or?
No, I think.
Okay, so this basically is the JavaScript client that is openly available for anybody, and you give it your own specs, and it generates this page for you. So here under the title, you see the link. That's actually the specification itself. And then it generates this. I can show you let's first go through this. So here various information, terms of service, and so on, and some comment. Behind the title, you see 1.0.0. That's the version of our specs, because it's the first we wrote. It's version 1. And OAS3 means basically OpenAPI specification version 3. That's the underlying schema for writing the specification. And then here you see the all the calls that you can do. They're all get calls for this, or for simplicity. And I can pick one, for example, this one, and open it. And here I see what the parameters are. This call takes 3 parameters: gene, phenotype, and less than value. And this also says what typical response is. And I can try it out. So I click on the try it out. And then I can actually change the parameters if I want to, but I'll just leave the ones that are here now. And if I press execute, it submits, and oops. Okay, and here is the response. And the response is this down here. So this is how the response looks like. And there's a number, so there's a number of other useful stuff here. There is curl. So this is a how a Unix command line would look like that submits the same call to the server and gets the same response, hopefully. There's also the URL itself. Since this is a GET call, you could copy this URL into your browser, and you should also get the same result in your browser. And yep, there's also down here a little bit of an example response, and media type is JSON, of course, and yeah, that's that. And also, yes, for every call, basically, we have an array and an object version. I should mention that the OpenAPI specification have, when you describe the response and the request, there are some limitations to what kind of responses you can describe. For example, if you choose the array output, you get something that contains an array of different arrays, like, for example, an array where the first element is an array of numbers, the second is an array of strings. Actually, the OpenAPI specs don't allow you to specify that. I can specify I get an array of arrays, but I cannot specify that different elements of an array of different types. So that this script is a bit incomplete, but the second one, object, that is completely described. So I guess those limitations are necessary to make like the code generation simpler. So is there anything else? Yes, and all this, what you see here is based on the specification, which is here under the title. I can open this, and this is how it looks like. It says OpenAPI version 3. It's called OpenAPI since version 3. Version 2 was called Swagger. There's some general info, the servers, and then, yeah, the tags are to group different calls together. Like if you look at the page, there are these titles like depict and eCaviar and so on. And components are predefined things. If you scroll down on the Swagger web UI page, down here you see some data models that we have. For example, if you click on variant, this is how it looks like. Variant is a consequence, a G and a P-value, and so on. And this is described by these components. So for every component, there's what kind of properties it has. So this is very similar to a JSON schema, except there are a few minor differences and some limitations, like, for example, that you cannot have an array of different things. And then if you scroll down after the components come the actual calls, and they start here, the paths. So after every path, you have the method, get, for example, what tags this belongs to, a description for humans, some ID, and then the parameters, a description, and where those parameters go, whether they're part of the path of the URL or part of the query part, and whether they're required, and also the format and the type. For example, this is an integer of format int32, and so on. And here is a response. And responses are sorted by HTTP code and content type, and then there's a schema, which in this case refers back to the components. Yeah, and that's basically how this goes. There's also examples embedded here. Yeah, and based on that, it basically generates that web UI page that you can use to basically learn about the API, try out some calls, and the specs you can use to configure your own tools or generate some code. Yeah, that's basically that.
Yeah, that's great. Yeah, I would just add that as someone who is not an engineer and not really comfortable with a command line or with Postman, this page is a great way to be able to actually run the APIs easily. So I would encourage you, if you're not an engineer, I would still encourage you to check this out, either by just running the examples that you get, or taking that URL, putting it into a web page, and then you can just modify the parameters in the URL, change the phenotype or whatever. It's really easy. So that's great. Okay, so I think we're going to hand it over to Noelle to finish up.
Great. All right, Maria, you can just show the slides. I can walk
Sure.
through.
Yeah.
Actually, I've seen some questions on Slack. They've been really great, and some comments about Postman and some comments from Andy. So everyone check those out. I think actually most of the outstanding questions have been answered on Slack. I'm not Slack, sorry, Zoom chat. Let me look and make sure. Yes, it appears they have. So any other questions from people? We can open up the floor right now. We have some time left. Or comments? Unmute yourself. You're allowed to now. No.
I've got a question here. Sorry, I'm the only one in the room who's here listening. So I was looking at the documentation. I was playing around with the API this past week, and it looked like if I just want to put in a region and ask, let's say I conducted a TUOS, I want to know in this region, is this novel or not? It seemed to say that only the largest data set would be returned. So I put in the region, I get back only the p-values for the largest data set for each variant there. But when I actually looked at the result, it seemed like it was returning a whole set of data sets. I wasn't clear which of those is actually getting returned.
Do you remember which one?
It was whatever's right on top of the API. So it's this get aggregated data symbol over here.
Yeah, what this does is this returns, so it's a region-based, but it'll return for each variant, it's the best, so it's a per data set. So it's per data set, but then for each variant, it's the best number.
Okay, so I will, basically, I guess maybe an
So
easier way to
we'll
ask.
get a mix, most likely. We'll get a mix across variants of what data sets. We usually have some DML. Showed up at the top most of the time, so.
Yeah, so maybe another way to phrase it is, so and this is from, a GOS was conducted by, not directly by me, but I'm responsible for this part. And the question is, if we have 7 loci that we can't find just by Googling them, can we confirm using the knowledge portal that these are in fact novel? Or can we confirm that no specific study has found this at p less than 10 to the 50?
Well, you can certainly do that with the portal, the web interface.
True. Yeah, and I guess if you only have a few loci, you can definitely do that.
Yeah.
Well, my guess is that this call would do it.
Okay.
That's my guess. Because it's per data set. Now, I can't necessarily speak completely to what I know of this call. Is I think so my understanding is for a particular phenotype, it'll give you the top score per data set per variant. So you'll usually get usually it'll be like one data set which will have the majority of rows, and then and I can't speak to the studies of blind evidence, but as far as based at least on the data sets that we have, I would assume that they try to make sense.
Okay.
But I would ask. I would talk to Noelle and Jason about that just to verify. Just so you know that when you go to the gene page, what you see on the gene page as far as the list of variants comes from this file.
So Mark, we're losing some of your voice on the phone, at least I am.
Sorry about that. So yeah, this is the get aggregated data call that we were talking about, and just what I was saying at the end was, if you look at the gene page, the list of variants comes from that call, the current list of variants, at least based on the current gene page that we have. So you'll get a mix of variants it's pretty much the best p-value based on combination of per variant, and it picks the best p-value, the data set with the best p-value for that variant.
So actually this is, the question in the room, I didn't fully hear it, but it would be really great because it sounds like someone's actually run a query to try and answer a question. It would actually be good, like Maria, maybe since you're in the room in Boston, to follow up and actually run that query again to see if it's getting the results we expect, and to see if we can actually make sure that our queries address the question that was raised. I didn't hear the full question, I'm sorry. But I think that would be a really cool expression of making sure these are doing the right things.
Yeah.
Cool. More questions from anybody? All right. So future webinars. Some topics for future ones will include, we will do a detailed webinar on the aggregation test that I mentioned, what you can do, what each of the results give you and provide you, so what the tests are themselves specifically and what you can do from them. We'll also take you through the new portal design, I think probably in March, what it allows you to do, how it looks different, how it still preserves the fact that we have these wonderful underlying communities that have contributed to our portal, that we want to retain some of their, some of that domain and that community sense, but also allowing the portals we've built for cardiometabolic disease to be more readily accessible and a common resource. So we can talk about that. We'll talk about new workflows that are available for gene and variant prioritization, methods that are run on the GWAS datasets and how to access those, not only from download APIs as those get better and grow. We'll add to our list of predicted effector genes and complications. And finally, we might have, well, hopefully our ABI colleagues will help talk about the federation that we have at EBI. And so those dates, Maria, if you don't mind going to the next slide, would be great. I think we're doing again every other month, which is slated for March 12th, same time, same day of the week, 12 noon Eastern Standard, and then in May and July. And obviously you can look for us in between. You can always email us if you have any questions. You can walk down the hall if you're in Boston. You can come visit us, but we are always willing to answer your questions and make the site as useful and better as it can be. So with that, I think we'll end. If there are any other questions. Sorry about the dog. She has a question. Apologize. She wants to know how to use the APIs as well. All right. Well, thank you all for attending. Again, we recorded these and we will post them on our website.
All right. Thanks, everybody. We'll see you next time.
Take care, everybody. Bye-bye.